So in this video we are going to be going over parametric equations, and to be specific, the question that appeared in quiz 1, question 4, where it said determine the x and y coordinates of the points where the following parametric equations will have a horizontal and vertical tangents, and sketch them. So now we're going to have our x being equal to t to the power 3 minus 3t, then our y being equal to 3t to the power 2 minus 9. So now we're being told to find our vertical and horizontal tangents. So now a tangent is a point where the derivative is 0, because the derivative is a tangent. And then when you have you have tangents, like for example, I'll give an example. If you have such a function which is going ahead, so you have tangents there, you have tangents there, but then a horizontal tangent is one which touches the highest point or the lowest point, which is probably this one. So looking at a point where the derivative is 0, because when the derivative is 0, we'll have a horizontal tangent. So now which ones are horizontal and which ones are vertical? So remember, when you have a function, let's say this is our y, this is our x. This is not parametric, by the way. When you have a function maybe like this is a function y is equal to x squared. So now what will happen is where the derivative is 0 is obviously this point, but then notice that this is the horizontal, this one here is the horizontal tangent, and the horizontal tangent happens when dy over dx is equal to 0. Now, in which situations can we have horizontal tangents? Well, when x is a function of y, such that when you have something like this one, this is our y, this is our x, this one, x is equal to y squared. When you try to plug in the values, you find that this is the function. So now the horizontal tangent is there, the vertical, sorry, is there. So now how do you find this vertical? This happens when you get dx over dy to be equal to 0. That's when you have this horizontal tangent. This is when the horizontal tangent happens. So this is because in this situation the function is in terms of x. So now when you look at these two, you're going to, from this principle, you're going to go back to this one, and you're going to notice which one is your vertical and which one is your horizontal. So according to this one, our vertical tangents are given by dx over d something, right? And then our horizontal are given by dy over d something, d there. So in this case we're having t, so dt. So I'm sure that's clear. That was just a brief explanation. So now you can go into the question. So we're going to find the horizontal. We can start with anyone. We can start with the horizontal. So now the horizontal tangents are given by dy over dx, just as I said. Dy by dx, when you dy by dt, sorry, when you differentiate y with respect to t, you're going to have 6t. So now at dy by dx by dt equal to 0, you're going to have 6t being equal to 0. So now at this point you can conclude that your t is also equal to 0. So now when graphing, we're going to be graphing with x and y. So now we need the coordinates where the horizontal tangent is. So now the coordinates will be given by our x coordinate and our y coordinate. And now the x coordinates, so you find our x at, so you can say at t is equal to 0, our x is equal to, well, when you look at the function, x will just be 0 as well, and then when you look at this one, x will be -9. But then let's solve it for the sake of solving. -3, 0. So your x coordinate is going to be equal to 0. Then your y coordinate is going to be equal to 3, 0 to the power 2 minus 9. Y is equal to 9 as a negative. So then you're going to have your horizontal tangent to be equal to 0, negative 9. So then we go to the vertical. You can do that and say vertical. So then the verticals are given by dx over dt. So now dx over dt is equal to 3t squared. This is just simple basic power minus 3 when you differentiate this one. So now at dx over dt equal to 0, you're going to have 0 being equal to 3t squared minus 3, and then when the 3 goes the other side, you're going to have 3 being equal to 3t squared. Divide both sides by 3, you're going to have 1 being equal to t squared. When you get the square root to make t a subject, t is going to be equal to plus or minus 1. So now you're going to have two values of t, so meaning that you're going to have two vertical tangents. The first one will happen when t is 1, the second one will happen when t is negative 1. So now you can say at t is equal to 1, at t is equal to 1, we're going to evaluate this one. So this one, when t is equal to 1, you're going to get this one, that's 1. Here you're going to have minus 3, so it will be negative 2. So x is equal to x will be equal to negative 2. Then what over y? Well, when t is 1, this one will be 1, that's t squared, and then 3, we have 3 minus 9, so this one will be y is equal to negative 6. So our first coordinate is negative 2, negative 6. Then now we're going to go at t is equal to negative 1. So now at t is equal to negative 1, negative 1 to the power 3 is negative 1, minus 3, this t has a negative 1, so this t will be positive. Then we're going to have negative 1 plus 3. So then our x is going to be equal to 2. Then our y is going to be negative 1 to the power 2, that's 1, times 3, that's 3, 3 minus 9, that's 6. So then our y is going to be equal to 6. So we have our vertical tangents to be 2, the 6 was negative 2, negative 6. Yeah, 6 was negative because we have 3 minus 9. So now we found our vertical tangents and our horizontal tangents, but then the question is going on further to say sketch and sketch them. So then for us to sketch them, we must also find as well the coordinates. We must find the x and y coordinates of the graph. So then to do that, we must make a table of values. So you can say x is equal to t to the power 2 to the power 3 minus 3 t, y is equal to 3 to the power t squared minus 9. So we've done half the battle. We found the vertical tangents quite right, but then we must also find the other values. So now you have t, x, and y. So now we will be changing t because we know both functions are dependent on t. So we'll see what happens when t changes. So you can pick maybe two values, 2 greater than 1, 2 less than 1. So have your 0 there, negative 1, negative 2, you have 2, you have 1, you have 2. So now we can get a calculator for easy calculations. So now I hope it's visible. So now we are saying for this one, when t is equal to negative 2, we are going to have negative 2 to the power 3 minus 3 negative 2. When t is equal to negative 2, x is negative 2 as well. You go to y, 3 negative 2 to the power 2 minus 9 we're going to have this one being equal to 3. Then we can go on to -1. So when finding the x, -1 to the power 3 minus 3, negative 1 again. Hey, why? -1 to the power 3 minus 3, -1. We have our answer to be 2. Then our y coordinate will be given by 3, -1 minus 9. That is 3, -1 to the power 2, minus 9. It's going to give us -6. -6. Even here, did we put the -2? Let's try again. For the first one, 3, -2 to the power 2 minus 9. Our answer is 3. Alright. Then we go to 0. When t is 0, x is also 0. When t is 0, this one will be 0, y will be -9. Then when we go to 1, when this one is 1, we are going to have a -2. We can just try that. 1 to the power 3, 1 to the power 3 minus 3 times 1, -2. Then we go to the other coordinate, y. So you have, this one will just be 3 because this will be 1. This will be 3 minus 9, which is -6. Then when t is equal to 2, you're going to have 2 to the power 3 minus 3 t2. So this one is going to be 2. And then this one is going to be 3. 2 to the power 2 minus 9. It's going to be 3. So now we have our points 1, 2, 3, 4, 5. So now when you are graphing, you are going to graph in the chronological order from 1 all the way up to 5, because what happens with parametric equations, I forgot to mention this earlier. Parametric equations, they are not, some of them come out peculiar, some of them do not, some of them are not straightforward, and they have weird figures. So you find maybe an equation is like that, an equation can come like that, can come here, can come back there, it can make all sorts of shapes. So the only way you're going to know that from, let's say I have coordinates here, and there, and there. So for you not to go maybe like this, you have to know to say this is point 1, this is point 2, this is point 3. For example, if you plotted points 1, 2, you would have to know which one to go first to, because when you have equations that are not parametric, we know to say, let's say it's this one, we know to say I'll just do this. But for parametric, it can come like that, it can come like that, it can come there and maybe even come back. So you have to be following the points. If this is point 1, point 2, point 3, point 4, point 5, point 6, point 7, and point 8, you have to follow them like that. So now we're going to sketch, and then the main sketch here is our horizontal tangents. You must remember that. So then to x, we have got -1, -2, 1, 2, 3. We can also add the 3 this side. Then in the y, we have 3. We can, I think if we put them 1, it will have to reach 5, because this one is ending at 3 in the x, but then in the y it's ending at 9. So you can say 3, 6, 9. The same here, 3, -, 6, -, 9, -. Then we can plot our points. Remember our horizontal tangents were 0, -9. So we have a horizontal tangent there. We can label it. You can write it down with the black marker. This is our horizontal tangent. So the horizontal tangent is, sorry, I didn't realize it wasn't visible on the camera. So the horizontal tangent is this one. this point is negative 0, 0 comma negative 9. And then for the vertical tangents, we have got negative 6. We have got negative 2 comma negative 6, which is there. So here we have got a horizontal tangent, and then at 2 comma negative 6 again, we have another horizontal tangent. So we've graphed the horizontal tangent, but then let's also sketch the graph. So now the graph, we are having coordinates 2 comma negative 3 as the first one, or negative 2 comma 3. So I've got negative 2 comma 3 as our first one. Then our second one is negative 2 comma negative 6. 2, sorry. So I've got 1. Then our second one is 2 comma negative 6. 2 there. Then our third one is 0 comma 9. That's our 3. Then our fourth one is this one. This is our third one, by the way. I hope it was visible. So our third one is this one. Then our fourth there is negative 2 comma negative 6, which is there 4. Then our fifth one now is 2 comma 3. 2 comma 3 is 2 comma 3 there 5. So then we're going to start from 1, we're going to go to 2 to 3 to 4, and then we're going to go all the way to 5. And thus we've graphed our parametric equations, we've shown the horizontal and vertical tangents, and we've sketched the graph. So that's all for quiz 1. Quiz 1 solutions are all done. You can try to check them out. There is a playlist that's written quiz 1 solutions, and then quiz 2 solutions are also test 1, sorry, are also done. So remaining test 2, but you just have to check them out. I'm sure they will be done before Monday.